Alright, so today we're going to do pair t-tests. And we're going to start out by doing problems where it says, not pair t-tests, but we have to do a test on the average time through a maze for lab rats. I want a 95% confidence interval with a margin of error of 1 minute. In the past, standard deviation was 5 minutes. How many rats should we test? So we have our reasonable estimate for S of x to be equal to 5, and we don't know what t star is going to be, so we're going to use z star even though we know it will be a t-test. So 1 equals z star sigma over the square root of n. Since we're doing a 95% confidence interval, that's the 1.96. The standard deviation is 5 divided by the square root of n. And multiply these two together, and that turns out to be 9.9 over the square root of n equals 1. Multiply both sides by the square root of n. Square root of n equals 9.9. So I'm going to square both sides. And so when I square, I'm sorry, that's not 9.9, that's 9.8. So when I square 9.8, we get the answer of 96.04, which I'm going to round up to be 97, because we always round up in these problems, and I can't have 0.04 of a rat. Let's try this again in example number 2. This time we want to do the same thing except for it's a 99% confidence interval. And the standard deviation that we're going to use once again is 5. And this time my margin of error equals 2 minutes instead of 1. So I'm going to do inverse norm of 0.005, because when you have 99%, there's 1% left over. So we got 0.005 or 0.5% on each side. That turns out to be 2.576. So 2 equals 2.576 times 5 over the square root of n. So when I multiply 2.576 times 5, I get 12.88 over the square root of n. So 2 square roots of n equals 12.88. Divide both sides by 2. And so 12.88 divided by 2 is 6.44. Square both sides. And I would need 41.47 rats. But once again, I can't do that many rats, so I'm going to use 42. Alright, so we're now going to move on to pair T procedures, and this is for basically experiments or surveys where we have a match pair type of design. So in this example number 3, we have a match pair experiment. So we're doing an experiment where we want to talk about the depression without caffeine versus depression with caffeine. And some of your teachers who drink a lot of coffee will tell you that this is a very real thing. So what I'm going to do is I'm going to subtract them all. So I'm going to do the depression with caffeine, without caffeine minus with caffeine. So a positive number like 11. Then person number 2 is 18. They really need their coffee. 1, 4, 6, 19, 6, 3, 13, 1, and then this one person who's strange at the very end is better without caffeine than with caffeine. So instead of the numbers being, so instead of Alright, so we're just basically going to use these 11 numbers as our data set. So mu equals the difference in depression levels I should say mean difference in depression levels for all people with caffeine minus without caffeine. And since we're doing a subtraction and each of these person was tested twice, this is going to be considered a 90% paired T confidence interval. So let's check our conditions. This is an SRS, but it's not an SRS because they were volunteers, but this is a randomized experiment. So even though SRS is for surveys, when we do an experiment, we're going to consider the fact that we randomize the experiment. Independence. Because this is an experiment, instead of doing the 10% rule, one person's depression has no effect on another. So a little bit different for the independence. And for normality, we cannot use the CLT, and they didn't tell us it was normal, so we're going to have to take a look at the box plot. Alright, so this picture of the box plot is slightly skewed, but not enough for me to say it's not approximately symmetric. You could say it's slightly skewed to the right, but that's not going to disqualify it. And there are no outliers, so I'm going to call this approximately normal. So now I'm going to get all of the data from one stat variable. So we have x bar equals 7.36. Sigma is equal to 6.91, or the standard error, and n is equal to 11. So 7.36 plus or minus something. Remember, my degrees of freedom is going to be 10, which is actually on the table. And so we got the square root, 6.91 over the square root of 11. And when I do inverse t of 0.025 with 10 degrees of freedom, actually we're doing 0.05 because we're doing a 90% confidence interval, I get the answer of 1.812. So plug these numbers in. And we get 3.58 to 11.15. So, as a result, I am 90% confident that people addicted to caffeine, I should have wrote that in the original that we're talking about, people who are addicted to caffeine, are 3.58 to 11.15 more points, right in here, I should say on average, 3.58 to 11.15 points less depressed with caffeine. And that's it for this one. Alright, so example number 4. For number 4, mu equals the mean difference in I can't even write that word. RESOANONCE brain or imaging between identical twins affected, unaffected, minus affective, I know I'm not going to spell this right, schizophrenics. HIZ. I didn't get paid for my spelling. So, this time we are going to do a 95% confidence interval, T paired confidence interval. Okay. SRS. And we didn't because this is a study. So we had volunteers, independents, each brain doesn't affect the others, and normality. So what I did was I put the first column in L1 and the second column in L2, and L3 equaled L1 minus L2. And so when I got the picture, it looked like the next slide, which is once again approximately normal. There's a little bit of skewedness, but not much. And there's no outliers, so I'm going to say approximately normal. So let me do the one variable stat. And it turns out that X bar equaled 0.199, sigma was 0.238, or standard error, I should say, and we had 15. So 0.199 plus or minus 0.238 over the square root of 15, and this time I'm going to do inverse T of 0.025, and we have 14 degrees of freedom, or you can look it up on the table. And it turns out to be 2.145. So we got 0.331 on the top end, because I did the plus one first. When I go back and do the minus one, it is 0.067. I am am 90% confident that the mean difference of resonance imaging between unaffected and effective is between 0.067 and 0.331 cubic centimeters. All right.